So a lot of the time when we learn some statistical concepts, we're going to take an example, like a real life example that took place or that is currently taking place to sort of talk about the concepts in that specific lesson. So we're going to talk about a controversial program that was carried out in New York City by the New York City Police Department called Stop and Frisk. And apparently, even though it's been declared unconstitutional by the Supreme Court, it's still used. Okay. And what is this Stop and Frisk program? Well, it allows people to stop people on the street, search them for weapons or contraband without any sort of evidence, or like if they suspect, they can stop and they can frisk. You can see the potential problems with that. Okay? But they don't have to necessarily have costs. They can just think, well, we're going to stop this person here because we're not sure. So during a stop, if the police find evidence of criminal items or activity, they report an offense. Then they either make an arrest or issue a summons to court. And they recorded detailed data on all of this. And here we see data from 2020 that looks at the number of stops and whether a criminal offense was reported by race. Okay? Because that's the potential problem with this, is racial profiling. And that's something that we're sort of going to address. Hold on here. Let's just say not cooperating. What is this? Okay, that's not good. Let's get rid of that. Get rid of that. Let's try again. Okay, that's not good. My God. Okay. Let's see if this works. I don't know why it's giving me black. There we go. Okay. All right. So first thing we're going to need to do some analysis here is we're going to need the totals. Okay. So what we want is the total number of, yes, there was a criminal offense reported. No, there wasn't. So stop and yes, stop and no. So just for saving time, the number of people that were stopped and a crime was reported was 3,684. People were stopped and crime was not reported, 5,000, or recorded, 5,637. In terms of the race of the people that were stopped, total Asian was 219. Total Black was 6,196. Total Hispanic was 2,050. Total White was 856. You can see the potential problems coming. What sort of jumps out at you? Yeah, the number of people that were stopped, because remember, all these people were stopped, okay? And either a crime was recorded, or it wasn't. So, and here's the total, by the way, 9,320. So out of like a little over 9,300, almost 6,200 that were stopped were Black. That's a little potential problem. Okay. So we're going to analyze this data, and this type of data has been presented in a two-way table. That's what we call this. Because It's a table of counts, the number, not the percentage or not the decimal. Okay? Describing two categorical variables. Okay? That's why we call it a two-way table, because it's two variables, but they're categorical. We're going to be looking at, remember we talked about quantitative and categorical in the last lesson? We're going to focus on categorical in this one. And what are the two variables described? Race of civilian. Because remember, that's not a quantity, that's a name. So it's categorical. Race of civilian and whether offense, crime, was reported. And again, that's categorical because it's not numbers, it's yes or no. So that automatically makes it a categorical variable. Okay, so you can obviously glean a lot of information from this table. For example, what proportion? And when I say proportion, your answer should be a fraction or decimal. When you see the word proportion. Only use percent if you're asked percent. If it says proportion, fraction, or decimal. What proportion of the sample were stopped by police and a crime was reported? Where would I find the number that were stopped by police and a crime was reported? Remember, they were all stopped. What's that? Yeah, 3684, right? Out of the total number of stopped, that was 9321. You can leave it like that if you want. Okay, you don't have to reduce. That's another nice thing. If you want to change it, because sometimes this gives you a little bit of a better idea, it would work out to approximately 0.395. We're pretty close to 40%. Okay? So about 40% were stopped and a crime was reported, which means 60% crime was reported. What percent of the sample were Hispanic and stopped by police, but no crime was reported? How would I find that? So the total Hispanic and under no, right?
Yeah.
So 1226 out of the entire sample. 9321. And again, you can leave it like that. If you want to convert, you would get, oh no, sorry, you can't leave it like that because you're less percent. Convert it to percent and you get approximately 13.2%. Okay. Now read these questions carefully. Okay. The first two questions, our denominator was the total number stopped. But that may not be the case. What percent of those stopped by police and a crime, so that means yes, were white? So we're not finding what percent of the total, we're finding the percent of those that were stopped and a crime was reported. In other words, isn't it just yes? Isn't the total yes, the denominator? And how many were white? 352. So we get 352 over 3684, which is approximately 0.096 or 9.6%. You may be thinking like, what? How much do I round to? Usually 3 or 4 decimal places is good. you're never, I'm never going to ask you to round to a certain number. Okay? Especially if you're changing to percent, definitely go 3 decimal places. And if you go 4, that's fine too. Okay. So what we can do to find further information from these two-way tables, we can do 2 types of distributions, marginal and conditional. When we're asked a marginal distribution, okay, we are taking the margin totals in the table over the grand total. And there's 6 margins. Yes, no, and then the 4 races. Okay? So we could be asked, find the marginal distribution of whether a crime was reported. That way we would go the number of yes over the total, the number of no over the total. If we're asked to find the racial distribution, we're going to find 4 percentages. We're going to find the number of Asian over the total, Black, white, Hispanic. So this is our distribution. Asian, well, 219 were stopped out of 9321, which is approximately 2.3%. Black civilians, 6,196 were Black out of total 9,321 that were stopped. Is approximately 66.5%. Hispanic, 2,050 were stopped out of the total number of civilians, 9,329, which is approximately 22.0%. And white, 856 stopped were white out of the total number stopped, 9,321, which is approximately 9.2%. So we can see, you know, we can, when we're calculating these things, we can always gain information, right? And this kind of jumped out to us at the beginning, just when we looked at the table, but now we can see it even further, right? I mean, the majority that were stopped were Black civilians, and not many Asian or white civilians were stopped. You can always get some conclusions out of data. Well, you can do calculations and present a whole bunch of numbers, but in statistics, another way to present information is visually, and that's by graphs. And how do you present categorical data? Okay, the counts of yes, no, the counts of race, we use a bar graph. And there are different types of bar graphs. There's a very simple one. So like if this wasn't here, that's just a simple bar graph. This one has got 2 bar graphs in one, or side by side. So kind of makes sense. We call it a side by side. We're going to create another one on the next page. So looking at this, first of all, we got to see what we're looking at. This is the distribution we just found up here. Okay? These are all the numbers from up here. This is the distribution of race in New York City. Okay? So we didn't calculate these. This is just given to us visually. What do you notice? Again, and we've talked about this, but how would you say it? Like, what's the thing that jumps out to you? Yeah, like
There's as many.
I mean, the number of the percentage of blacks in New York City is 25%, yet 66% were stopped out of all the ones that were stopped. That's the big one, right? And the other ones were all lower. Like Asian people represent 15% of New York City's population, yet only 2% were stopped. This is Hispanic. 30% of the population in New York City is Hispanic, yet only 22% were stopped. Almost a third are white, yet only 9% were stopped. So we could kind of say it two ways. Black civilians were stopped at a much higher rate than their representation in New York City's population, or in NYC's population. And a lot of times, you don't necessarily have to do it, but you can include numbers. You know, so you could say black civilians were stopped and then put in parentheses 66% at a much higher rate than their representation, which is 25%. All other races were stopped at a lower rate. And they're just trying to show that population representation. In NYC. Okay. Make sense? Okay. So distributing by margins gives us some conclusions we can make. We could also just distribute what we call conditional, where we don't use the grand total as the denominator, we use the margin totals. Those are our denominators. So it would be things like of all the Asian civilians, then you go to that margin total. Of all the white civilians, then you go to that margin total. Of all the ones where a crime was reported, you would go to the yes margin total as your denominator. And then, for lack of a better phrase, when I talk about cell, sorry, I'll say cell values, not cell totals. Cell values. Those are the ones that are sort of inside the table, not the margin totals. It's like the original table. Okay, so how can we use this in this case? Well, the former mayor of New York City, who expanded Stop and Risk, you can see there, was speaking about the program in 2015. I believe this is shortly, well, I'm not sure if it was shortly before or shortly after it was declared unconstitutional. Because I believe in 2015 or 2016, that's when they declared it. So he was talking, people say, oh my God, you're arresting kids for marijuana who are all minorities. Yes, that's true. But why? Because we put all the cops in the minority neighborhoods. Yes, that's true. Why do we do that? Because that's where all the crime is. It kind of sounds like circular reasoning. Okay. So basically what he's doing is he's trying to justify it. To say, you know, this is where the crime is happening. So that's why we're doing it so much in those areas. And when when he talks about minorities, referring to the black civilians. Okay. So let's see if that's actually true. Let's see if that's, you know, is that where the crime is happening? So we're going to calculate the crime rates among each racial group. So that means our margin totals, okay, are going to be the 4 totals for the races. So for Asian, calculate the crime rate. So yes. So how many were yes and Asian? Yes and Asian. 77 out of the total Asians that were stopped. 132, and then we convert that to a percent. 132 should be 219.
42. 140.
No, 219.
Oh, sorry.
Approximately 35.2%. And so that's how we would find all these numbers. So black would be 2,431, where crime was reported among black civilians. Out of the total number of black civilians that were stopped, 6,196, which is 39.2%. Hispanic, is 824 were Hispanic and a crime was reported. Out of a total number of Hispanics that were stopped, 2,050, which is approximately 40.2%. And I need to space right here for the graph. So whites will be 352 stopped. For white crime is reported. Out of the total number of white civilians that were stopped, 856. Which is 41.1%. Now we're going to construct a bar graph, and we're going to construct a segmented bar graph. I'll show you what a segmented bar graph is. First of all, we need 2 axes. And we're going to use 4 bars. Okay? For Asian, for black, for Hispanic, and white. So I'm just going to put that. There's no numbers to put in. Okay? For the vertical axis, we don't want to put the counts. We want to put the percentage. So remember, good graph starts at 0%, goes up to 100%. So there's 50. I'm going to go up by 10s, 60, 70, 80, 90. It's not perfect. 10, 20, 30, 40. So we're going to draw bars for the ones where a crime was reported. So 35.2%. Different color. So 10, 20, 30. There's 40. So it's about halfway between there. So we're looking at that. Somewhere around there. For black, you're almost at 40. So just a shade under 40. And you want separation between the bars too. You don't want them side by side because that's actually another type of graph. Hispanic is slightly higher than that. And white is slightly higher than Hispanic. So this is, remember, I'm sketching it being perfect. So that's one segment that yes. Okay, so this represents yes to a crime. But I also want to show the bars for each race where a crime was not reported. So all I have to do in that case is just fill in a bar all the way up to 100%. So eventually, they're all going to be, all the bars are going to be the same heights, but they're not going to be split the same way. And that is what we call a segmented bar graph. So you're taking all of the possibilities in one categorical variable and drawing one bar and splitting them among those possibilities. So like if I had yes and no down here, I would have 4 colored sections, wouldn't I? Because I'd say, okay, out of the yes, I would have a certain amount percentage for Asian, I'd have a certain percentage for Hispanic, and a certain percentage for Black, and a certain percentage for white. Now, the College Board seems to be leaning towards no longer having students create graphs. But I still think it's valuable just to do it. Okay? But in terms of the College Board exam, you can pretty much expect that you won't be asked to create a graph, but you will certainly be asked to analyze graphs, like we are about to do here. And this is an important word in statistics, association. Okay. What is an association between two variables? Knowing the value of one can help us predict the other. That's very different than causation. Knowing the value of one predicts the other. Okay? It helps us to predict, but it can't necessarily predict. Do you see any kind of association here? Is there anything how you could explain? So what we want to talk about here is the association between race and number of crimes committed. Who does the most? White people and Hispanic, right? Yeah, see. What about Black people? So many that were stopped. Well, the number of Black crimes among the Black people is actually quite low. Okay? Lower than it is for Hispanics and lower than it is for whites. And not a heck of a lot higher than Asian. Okay? So, there seems to be association between white civilians and higher crime rates. I mean, if you want, you could include Hispanic in there because it's pretty close to white. But you wouldn't say there seems to be an association between Black civilians and the number and crime rates, because it's lower than the other race, than two other races. Okay? So when you describe an association, keep this in mind. Okay? Make a claim, as in yes or no, there's an association, or no, there isn't. Yes or no? Support the claim by comparing groups. Or if you're doing it from a graph, bars. So you may want to use the percentages to describe the association. You may want to use the segmented bar graph. Either one is fine. Okay? And always in statistics, always include context. What do I mean by context? Don't say, well, it seems as if there's a higher percentage among a certain group. I really didn't give you any information, did I? Higher percentage of what? What groups are you talking about? Men and women? Okay? That's what it means. Context means you include words from the actual situation. So I said there seems to be an association between white civilians. That's context. Higher crime rates. That's context. Okay? You always want to do that in statistics. You don't want to say, you know, when we get to things like mean and standard deviation, the mean is 78. You need to be a little bit more specific than that. 78 for what? What's the context? Does that make sense? Okay. Like I said, an association does not necessarily mean causation. For example, I looked this up. The number of students in North America taking AP Stats has been increasing. And what was, I can't remember. I looked at a type of cancer that was also increasing year after year. Okay. We can say there's an association between the number of students taking AP Stats and a certain type of cancer. But can we say if you take AP Stats, you're likely to get this type of cancer? No. The first thing I said was association. The second is causation. Okay. Taking AP Stats does not cause this type of cancer. I mean, that sounds ridiculous. So, the comments that Bloomberg made above, the quote, is it supported by this data? No. Right? No. Because, you can say it this way, there was a lower crime rate among blacks than whites and Hispanics. Doesn't make sense. What's making it look bad is the number of black people that were stopped. That's what's making it look bad. That's a really high percentage. But when we dig a little deeper, we can see, yeah, okay, the majority that were stopped, almost 2/3 of the 4 races that were stopped were black, but they certainly weren't the ones that were committing the most crimes among their race. And that's essentially what the discussion says. So for this lesson, I'm not going to worry about the discussion. There, I have some notes on it in the notes in Teams. You can look at it there, but I mean, just, well, maybe very briefly, you know, they came up with, somebody came up with some data, you know, saying this, and we calculated these amounts and saying, well, 66% are coming from, of the crimes are coming from black civilians. Yes, because so many black civilians were stopped. That's why. So this new analysis does not provide any compelling evidence. Because the number of black people that were stopped compared to the total number of people stopped is ridiculously high. Okay, that takes care of that one.